Today we're doing Module 5, Lesson 7, and it's a very simple learning goal today. We're taking everything we've ever learned about volume and just applying it to a real-world context, to word problems. Word problems are just math problems that have real-life contexts, right? So it just helps you see how we use these math formulas and math expressions in real-life problems. An example of one of these real-life problems is this problem of the day. It says, Jeffrey builds rectangular planters. Remember, a planter is just a box, a rectangular box that people put soil in, and then they put seeds, and the seeds sprout into wonderful flowers. The question says that his first planter is 8 feet long and 2 feet wide. Okay, I can tell you right now that that's going to be important information, right? 8 feet long and 2 feet wide. Then the container is filled with soil to a height of 3 feet in the planter. The question's asking us what is the volume of soil in the planter, and we have to draw a diagram. Okay, so basically this is his planter. It's a rectangular box, isn't it? Okay, now is it filled all the way? We don't know. But we do know it's filled to a height of what? So let's say it's filled up to here. Okay. That means that up to there, from here to here, is 3 feet. How long is the planter? 8 feet long. Good. And the last dimension is the width. How wide is the planter? 2 feet. Is it asking us to find the volume of the entire planter or just the volume of soil? Soil. Do we have enough information to find that? Do we have enough information to find the volume of the entire planter? No. We would need to know how tall the entire planter is. But we do know how tall the soil is. So using this information, what math sentence could I use to find the volume of soil inside the planter? Nithya? Excuse me. Yeah, we could do 3 times 8 in parentheses times 2. If I'm doing that, I'm finding, by the way, that this is the top of the soil. Here's the 3 feet, and here's the 8 feet. So I'm finding this area first, right? And then multiplying it by the width, putting all those layers of area. Make sense? What's 3 times 8? So this is the same thing as 24 times 2. What's 24 times 2? 48. Okay, so my answer is 48, except that would be wrong because it needs what? How many dimensions did we calculate here? Show me with your finger. Nice, 3. This is how Jaden did 3. The width, the length, and the height, right? 3. So what kind of units do we need? Cubic or square or regular? Cubic. And what kind of units do we have? Feet, so it must be cubic feet. Very good. Okay, this word problem about Ren making rectangular display boxes. The question is asking us to find the volume of the display box, and the important information, we know that it's 6 inches long, 9 inches wide, and 4 inches high. Should we be able to find the volume there? Go ahead and calculate the volume. If we're going to draw a picture, we know it's going to be a rectangle, and we know that it is 6 inches long, 9 inches wide. I clearly did not draw this to scale, but that's okay, and 4 inches high. I can find the volume by first finding the area of this rectangular face, which would be 4 times 6, yes? And then I multiply all those layers by how deep it is, over here, which is 9 inches. So what's 4 times 6, everyone? 24 times 9. Okay, so I have to do that. I don't know my 24s in my head, so I can use my trusty old standard algorithm to finish the work. Did you guys get to 216?
Yeah.
Good. And what would the units be? Jaden? Cubic inches. Very good. So we can say that the volume of the display box is 216 cubic inches. Once again, using what you know about volume to solve a word problem. That's all we're doing today. Is it super hard? No. In this problem, step 1 is show 3 different ways Ren can make these boxes. And what you need to know is all 3 boxes need to have a volume of 60 cubic inches, and you need to draw diagrams and label the measurements. So if we get a word problem that tells us what we need the volume to be, and it asks you to come up with the dimensions, it's basically asking you something times something times something will be the volume that's given to you. In this case, it's 60, right? So you have to find the measurements. Does that make sense? So it's like the opposite of what some problems do. Some problems give you the measurements and tell you to find the volume. Some problems give you the volume and tell you to come up with the measurements. Do you see how it can go either way? Very good.